Good morning, everyone. My name is Stuber with American Hakko, and we're here at APEX 2026 in Anaheim, California. I'm here to show you a demonstration of the DOGA interface that is connected to our ATX P2 transducerized torque system. So let me show you how this works. This is the DOGA Smart Arm. This DOGA Smart Arm has two high-precision encoders that are built into the arm. And by using kinematics, it can actually determine where the position of the driver is in the XY plane. This is actually communicating through this position control system up here, which is speaking to our ATX P2 down below. So what we're going to do is we're going to pull a bit from the bit selector, and of course it lights up green telling us that we have the correct bit for this application. We're going to go ahead and insert it inside the arm, and we're going to go ahead and take a look at our torque curve. Now in this particular case, this system is programmed for a very specific pattern. Because if you're going to be using the ATX, obviously it's a critical fastener. And if it's a critical fastener, then it probably has a critical faceting pattern. So we've programmed in a pattern here on column 2 of our test board, which is going to go from the top, bottom, alternating back and forth, and then up for the next 2. So I'm going to go ahead and step to the other side and actually drive that, and you'll see as it works, you'll see the torque result appear up here, and you'll see the screw count appear at the top. When the driver gets positioned over the correct screw, you'll see that it lights up with the ready indicator. You'll see that the 2 position screen here shows that we've got green coordinates. If I were to move this off of the screw, the ready light disappears because I'm no longer over the correct screw, and I now see a non-green indicator from my position. So I'm going to go ahead and go back to the correct screw here and drive this down. I have a green light below. I see I have a good fastening here, and I've completed 1 of 6. Now, if I were to go to the incorrect screw in the pattern and attempt to screw this down, you'll see that the controller is telling me that it is being prohibited by the DOGA system. If I do go to the correct screw, which is at the very bottom for the pattern, it'll allow me to trigger. And you'll see now I've completed 2 of 6 on the DOGA system. And now I'll go ahead and repeat this process all the way through in the correct pattern. Again, the idea behind this is that since these are critical fasteners, the fastening pattern itself is also critical. And this ensures that the operator using the tool is doing the correct pattern all the time.